going on?
Hello.
Make sure I'm recording. Yes. I think here comes Brendan. I know Stephen can't come and Sean can't come because he has another meeting. So I was going to.
I don't have anything yet. If I get it today, that's good. I'm going to get Mystic Air in there Monday or Friday to do their the hazardous material survey.
So Sean will go on Friday, and if anybody wants to go with Sean, it's going to be at 2:00, and I'll record his and share with you guys. I think there's way too much agita, Roy and Daniel, on this part. This is not about pass fail. This is about just have a little fun. Whatever.
Maybe Friday, most likely.
Gotcha. So I have to say that I've never taken any statistics class at all. So
Yep.
It was very fun to learn this side of things that I had no idea about. So, it is what it is. I learned a lot. I still don't understand fully how to take the data and process that and derive anything from it. But
Yeah,
we give it the best shot we did.
Yeah, I think based on what you showed me, I think you pulled out what you thought was important, and maybe we can get through 10, 15 minutes. I don't know who wants to go first.
Can I go first?
All right, Daniel wants to get off the hook. All right.
Do you want me to email you my presentation, or do you want me to just share it through here?
Yeah, I can give you the controls, Daniel.
Okay.
And then you can share it if you don't mind, and then you could pass it to Roy
Whoever.
or Sergio.
I'll go next. That's fine.
Yeah, these guys want off the hook fast.
Yeah. Oh yeah.
All right, so now you are the host, Daniel Mendoza.
Nice. Okay.
Way too much agita.
Okay. Can you guys see my screen? Everybody?
Yep.
Okay. I'm gonna go. Okay, so this is Bill's Health by me. Okay, so this is the Z test. Let me just put this here. My bad. I did a Z test. Was Bill's average weight the same from 2006 to 2019 versus 2020 to 2021? So the null hypothesis is that Bill's weight was not different, and the alternate hypothesis that Bill's weight was different. So I did a small Z test and a 2 sample from the means. So the two means were different, 184.4 and 185.9. The variance was quite a bit bigger in the first one because there were 616 observations for 58. But the Z score I got was -5, and the Z critical two-tailed test was 1.959. So the alternate hypothesis that Bill's weight was different between the two variables was that's what I got from this, from the data. I did a normal distribution chart of the weight. So as you can see, the average weight's around 184 something, and on a high range it's almost near 200, and on a low range it's near 175. So this just gives you a visual representation of how the weight is distributed. What Bill ate that affected his weight during the lockdown. So you got 35 cups of frozen yogurt, 20 donuts, 15 bags of barbecue chips, 7 cups of carrots, and 5 cups of broccoli.
Got the beer.
Pareto chart of this, and I found out that the junk food consisted of 85% of what Bill ate during the lockdown. that frozen yogurt, he's got to lay off. And I'd say consume more broccoli and carrots. So this is my final suggestion is do not eat the leftover frozen yogurt at your wife's yogurt shop. Instead, eat more broccoli and carrots.
I write that down, Daniel.
So I did over the years a control chart of Bill's weight, and there are two outliers above. So as you can see at the beginning, it passes the upper control limit right here, these 2 points. And there was quite a bit of shifts and trends. As you can see in the middle around here, there's a shift going on where it's below the mean for a while, and then it creeps back up, and then it's a little bit inconsistent. So there's a lot of shifts and trends in the weight, as you can see over the time period. Here's a chart of his upper blood pressure. And this one's a little more consistent, you know, a little more in control. But at the beginning, there was a couple outliers. But as it became to the middle and the end, it was a little more in control. There was still a few that were out, but looks a lot better. The other one. And I did a control chart of the lower blood pressure. This one's a lot more up and down, the lower than the upper, as you can see when compared to the other one. And there's two outliers, one at the beginning and one at the middle right here. And this one's almost an outlier. But yeah, a little more up and down here. So it's not completely in control. I did an ANOVA test, and the question was Bill's heart rate similar throughout the day? The null hypothesis is yes, it was pretty constant throughout the day. And the alternate hypothesis, no, it was not constant throughout the day. So we're going to figure that out with this data that I have right here. So these are like 3 shifts in the day, 8 hours each. So as you could see, 12 a.m. to 8 a.m., he's sleeping. So the heart rate is going to be a lot lower. And then here it's throughout the day, and he's probably working 8 a.m. to 4 p.m., you know, has his shifts, nothing crazy, but more than sleeping, resting heart rate. And then 4 p.m. to 12 a.m., there's a lot of variation here because he works out for the first 3 hours here.
Like clubs.
And then after that, he's just like resting for a little bit, maybe cooks a little bit, a barbecue, and then he gets some rest near the end, so the resting heart rate goes. So this is how the ANOVA test went. So the 3 groups is the summary. 67 was the average for the sleeping period, basically. Throughout the day, it was 83.8. And then the last group, it was 85.3, but with a lot of variation, 219, it says. So as you can see here, the F value and the F critical are different. They're different values. And you can see that the F critical value is smaller than the F value. So that's something to look at. You'll see at the next slide what that actually means. So the F critical was a smaller value than the F value. Therefore, I reject the null hypothesis and accept the alternate hypothesis. And that was what? That was the heart rate was not constant throughout the day. That was the alternate hypothesis, and that's the conclusion I came from. So I did a small FMEA. Was Bill's mental health during the pandemic? How was Bill's mental health during the pandemic? What affected it the most? So not meditating, didn't exercise, working long hours through the computer. So I just did a little chart here. Meditation, exercise, long hours. So the severities, the occurrences, and the detections. So as you can see, they all have different numbers, and the RPN right here is which one's the most important. So as you can see, working long hours was the most important. It affected his mental health the most. And then you can see exercise, then meditation. but yeah, definitely the pandemic affected a lot of people with this. So, something to look at. And then I did 5 whys. Why was Bill Grader's Six Sigma class good?
Oh, geez, you already got your A. Stop.
Less stressful. And then it says because the class was spaced out. And then that was why. Why? Because spacing out things allows us to soak up less information. Soaking up less information prevents information overload, and information overload gets you confused. So that's the good reason why you don't do that. So, yep, that's my presentation, and hope you guys liked it.
Well done, Daniel.
Very nice.
The 2 hypothesis tests, Pareto, FMEA. Let me ask you a question, like the variance on slide 2. On slide 2 of your presentation, the variance over the last, how many years was it that you separated it?
Yeah, it was 2006 to 2019, and then 2020 to 2021.
So doctor, there's less variation in my vital statistics even though my weight's higher and everything else.
Yeah.
Thank you, doctor. That's freaking really good. Well done.
Good job,
Thank
Daniel.
you.
That was awesome.
Thank you, guys.
Would you hand it over to Roy? The controls, you just run over his name and you'll see more.
How do I stop sharing?
I think you're all set.
How do I
sharing.
change it out?
Yeah, hit participants.
Multiple participants or participants? Okay.
Yeah, then you'll see clicks on your right. Just go
Okay.
over Roy and you'll see more, and then
Yep.
just say make host.
Make host. Okay.
Okay. I
Nice,
think we
Daniel.
got it. I think we got it now.
Now your
Awesome.
blood pressure just dropped, Daniel. I get
I
more
know.
texts from this guy.
That was stressful.
Oh, I'm pretty sure I'm second in line, so.
Yeah, with stress.
Just from this, so.
That exam, everybody nailed.
So everybody can see this okay?
Yeah.
Do we have it on the right one?
Yeah.
Okay, so, like I said, I did it sort of a lot less or simpler than most, so we'll take a look here. So I started out with doing some descriptive statistics of the 4 categories: the blood pressure, upper, lower, the weight, and the pulse. So we did all the min, max, range, mean, mode, obviously all the standards so we can get the chart. It was interesting to see because when we did the samples for the homework, it was more of a nice curve from the information. And this one here was a sharp peak here. So you see it peaks probably right around, 125, 130-ish in the front for the blood pressure upper. So then I moved on to the blood pressure lower and I ran the same thing. Like I said, I don't have a lot of experience in this, but it was odd for me to see the chart go all the way down on the right side and then not all the way down on the left side. So
Chi-square.
trying to do this, but you can see how it peaks right around 80 on the blood pressure lower. Then moved on to the pulse, obviously, and the charts or the lines get more sort of spread out here, or there's a lot more to see. They're not so grouped together, and we're peaking right around 65 on your pulse. And then weight obviously looked like more of the sample we did for homework, a nice, more clean curve here, and your weight stayed average right around 185-ish, a little less, 183. So then after that, I took the information again and ran it through some control charts and did the blood pressure upper first. And as you can see, I took a range here because it was just too much information. The chart was all like jumbled together. So I did the last 5 years for all four categories. And you can see we approach over the upper control limit twice or around 3 times here once in the beginning and then twice down here towards the end. We went that way, and then I moved on and did the blood pressure lower. I ran this one a couple times, so maybe Bill, you can help me out with this one. I don't know why the line went straight on this. I don't know if anybody else had tried this and still came up with this, but I selected the data different ways, and I did it about 10 times, and it came out the same straight line every time. So instead of just eliminating it, I kept it in there just so if it was a mistake, I could learn from it. But this was the only one that was a straight line. It wasn't the jagged line.
Yeah.
So
Yeah.
I just thought it was inconclusive. I don't know what else to drive from that. So I just ended up moving on. And then obviously I moved on to the pulse over the last 5 years. And it was really interesting because this one went over the upper control limit about 4 times, which I thought was a lot. And you can see in the beginning here, it went way above the upper control limit. So you got 1, 2, 3, and 4 times. And then I moved on to the last one, which was weight. And just looking at the numbers from myself and reviewing this, I thought that this line would be more closely related to the median and not so much so over the place. I mean, you can see right here, it goes down below and touches the lower control limit, and then it spikes back up and goes down. So there is a significant lower number in the beginning, and then towards the middle, you kind of peak out at the top, and then it settles down to like the last 2 or 3 years, it kind of stays right around the median. So it looks like you have more control over your weight recently, probably because of things you've learned or changes in your diet. So, and that's all I got.
I love it. I don't think I've ever, no one's ever approached it where you're gonna look at each of those vitals, and I'm interested to see if they were a normal distribution. In other words, your health is a whole bunch of processes, really, and all we're doing is measuring those processes. I'm actually
Sure.
thinking about, keeping track of hours slept, because you can do it so easily now, with
Right.
my wrist and everything. But I think that was an interesting approach to it, the way you went at it that way. And
So I think it's also real interesting to see some of the guys that work with this or have worked with this on a regular basis and the ranges of what people come up with, because the 2 examples were phenomenal. And maybe it was easier. And like I said, I've never taken any class like this that's done with statistics. So a lot of these terms are brand new. I'm
Yep.
still in the training wheels phase, and some of these guys are like whipping through this stuff and picked up on it real quick. So it's interesting to see everybody's take and where their learning level is and how deep or how expansive they can get and how well they can get it. So
I'm very excited about, the fact that, as a project manager, managing many construction projects, and starting to, doing some measures. And I think it looks like you're going to go towards, control charting and, getting the data to talk, especially as we
yeah,
start to,
it's
especially
right.
as we start to go through the percent plan complete,
Sure.
and using that data and making it talk. So I think it was a good representation of where you're at. That was excellent.
Yeah, it's definitely another tool for us in construction, I guess, to sort of look at to kind of get more definitive answers. I mean, sometimes we're just sitting there, writing down on a piece of scratch paper with a pencil what's going on and doing that. Construction kind of lags behind the technology field a little bit here.
Like if you talk to the Olbrich people, for sure, and Daniel probably, I mean, when you say, well, how is it better? Yeah, this is how much better. Where, in construction, it's like, yeah, it seems
Right.
better.
Yeah,
So-
exactly. No, exactly. Well, we're ahead of schedule, so we're
Yep.
moving forward. That's like the main thing, right? If it's complete and we're ahead of schedule, that's like 100% for us.
Yep, and you don't have too much agita. Yep.
Right.
All right, who wants to go next? Well done.
I can go next.
All right.
Hold on 1 second. Oh, where we go? There we go.
Sergio had the third most agita.
Well, Sergio is always. Can you see my screen?
Yep. Then he pulled off a 98 on the exam. Mr. Nervous over there.
Well, this is the thing, and I need to make a couple of comments, if you allow me, before I give my short presentation here. I mean, part of my personality is always a little critical, and I want to kind of second what Roy said. I did enjoy the class a lot. I think I learned quite a bit, but I also think that this is not a 3 months class. To me, this was more of a refresher class for most of you. I see Daniel, I see Brandon, Stephen, obviously Bill and others, where you guys had a very strong understanding and basis for statistical analysis and Excel's skills, which I don't have. So I was a little in trouble. I think you went a little too fast because, regardless if I passed the test or not, I have the feeling that I grabbed only a very short percentage of what you presented, Bill. And now the concern I have, it's not a concern, but it's a responsibility that maybe comes with having passed this test. And I feel like, I'm not in any way ready to lead a Six Sigma analysis on behalf of the company. This said, and I stopped whining, I did come up with a case study, which I was really tired of Bill's health and blood work and polls. So I came up with something completely different. And I don't know whether in doing that, I messed up entirely, but hey, this is what I have.
No, you actually, I
ahead.
love it. Daniel actually made up a lot of data. That was one of the text messages. So, yeah, it's like whatever you take out of this, I'm happy. It's something maybe you didn't have when we started.
Right. Let me put this away. So, my case study is something that I was thinking about a program that we use within Ulbrich. It's a program called CRM, what is Customer Relationship Management, I believe. And it's a software we use. It's a large database in which we are supposed to gather all information that comes from the customer, And it's a great tool that we have. So the case studies you can read in a cafeteria of the company, we are discussing after the latest meeting in which upper management dictates the use of this CRM program because it's a great program, but also because it takes only 5 minutes. That's what they all say to us. Hey, it takes only 5 minutes. You should always put information in there. So people have a little bit of discussion. Some people say, of course, we'll do it. Some people say, no, we cannot. We cannot say no. We have to do it because management wants it. And then one guy says, no, it does not take only 5 minutes, and I will prove it. So he decides to put together a case study. And this case study, when it applies to the 4 tenets of Ulbrich, which is something that maybe Roy and Daniel are not familiar with, but I wanted to make sure to outline how this study could affect our credo, our motto at Ulbrich, pretty much. So the first part of this project was very simple in a way. I gave the project a name. I called the business case. It is a fact that only 30% of activity is recorded in our system, whereas we collectively as a company, we process hundreds of thousands of information every year. And project benefits, the scope, the key metric, I put some dates for the goal, but we need to move from 30% to 60%. The team members, I put some dates for the project to be carried out. And then, of course, as we progress, we will set the actual dates. And these are obviously define, measure, analyze, improve, and control, which is what we have learned over the past 3-4 months. I put together a little process map And I guess for my particular skills, this part was a little easier because it's more of a theory than math. But as you can see, I have the input, output, identify the problem, move into the different aspects of what takes for this project to be carried out. And then I put together this is pretty much the same thing, I guess. The steps more in details of what I decided to analyze. So for the define, I showed it already. And then here when analyzed, I put together a Pareto chart simply because it's the first thing we did. And I wanted to make sure to see that indeed 20% of the employees, they account for 80% of the inputs that goes into CRM. And apparently the chart seems to confirm that based on the random numbers I put in there. So I was happy that the Pareto worked for once. And then I was trying to put together to see if there is a correlation between the number of years of employment and a number of inputs that each individual person goes into the system and enters. And the correlation results, oops, sorry. There is no correlation. As you can see, it's completely off the chart, meaning that it doesn't matter how many years of employment you have. Maybe as a matter of fact, people who have been there less time proceeds at entering more data into the system. So it's not really, the R factor is 0.233. So it's all over the place. It's not towards +1 or -1. And then I proceeded to putting together the test here. And I based it, I believe, on a 95% confidence level. So at 95% confidence level, is there enough evidence to support the idea that the less than 5-minute statement is correct? Since it could be more or less than 5 minutes, I conducted a 2-tail test. I believe that was correct. And to run a z-test, I suggested that this person did at least 30 samples to have the normal distribution z-test. It's a normal distribution, and the result of what I came up with, assuming it's correct, is that with 95% of confidence, we can say that the statement is not correct, and we reject the hypothesis. Next, I put together the CTQs, critical to qualities. As Daniel showed, I try to categorize and assign a score to what's more important, the most important variables to pay attention to, and it came up to the accuracy of the information given from the customer. Very important to understand our, when I say website, I mean our CRM program, and also how accessible and easy to navigate our CRM program is. And based on these 3 results, I did run the failure mode and detective analysis. Oh, what did I do here? Yeah, the severity, potential cause, and I came up with suggesting action items, which imply to better train the inside sales team, as well as maybe involve the IT group to make this CRM program even easier to read or to access. Finally, I did try to run here a statistical control upper and lower limit. And granted, this was a kind of very large standard deviation. I don't even know if it applies to my case study, but
How many inputs are there?
I put 52 because it's 52 weeks in a year.
Okay.
Or I put one input per week and a number of entries per week, which, you know, it varies. And I'm not sure this applies really to the case study. And last but not least, you know, based on what we learned, I put some recommendation together, including trying to come up with a Pokayoke, which it's not really a mistake-proof system here, but I was wondering if perhaps it's possible that this CRM software becomes part of Outlook, so it's always open regardless, instead of having to access separately, which maybe some people don't do. And yeah, you see my recommendations to make sure that the platform works and becomes even more effective to what we need to do. So nothing really fancy in a nutshell, but again, I didn't want to work on Bill's health, and I came up with something else, which maybe it wasn't
Sergio,
worth
I
this
freaking love you.
analysis.
You know,
I
Well,
like it.
I just love you. Because I never had anybody say, screw Bill's health. We're not going to do that. And just take it in this direction.
I didn't mean it that way, but everybody
Well, the
else.
business case, right? The business case is, all right, because I've heard this being at Albrecht for a bunch of years. It's like, that it's underutilized, the CRM. What if it was really used well? What if everybody contributed to it in terms of a tool, and just the approaches? Like, I think going forward for this course, and I'd like to talk to you offline in terms of the amount of time, the number of weeks this has taken. But I disagree with you in that I think that you got the spirit of what what the DMAIC is and what we're trying to do, no question. And I also feel like, as a green belt, if you wanted to approach this as a business, a business case for doing a project on how do we get better participation, make it easier to use. It takes a lot more than 5 minutes. It's there's mistakes that can be made. It's not that simple to use, whatever. Even if you had, guidance of a black belt, that's how it works. In a green belt position, the project charter gets worked on as a team and you kind of work through it like that. But I think from now on, I'm going to give people the option of, one, you could use my health data, because it's really the only data that I have to give you. Or two, you get something like you just did. Because I think it was beautiful. I loved it.
Well,
How about
thanks.
you guys? What do you guys think? Sergio.
I'm not sure it was really pertinent, the example, compared to the data to prepare, but that's what I had.
I think it is. You took a problem and then you started thinking about, all right, how do I go through the domain? And you kind of touched on all of them, on every single, all DMAIC, all the way through. That's well done. Really good.
Thank you.
Yeah,
This was pretty interesting.
I thought it shows that you don't need tons and tons of data to take this approach to problem solving and to working through a project. So I thought it was very creative. Well done, Sergio. All right. You guys see everything okay? See the screen? All right. So this obviously, going back to Bill's health data. So I took the DMAIC approach to this process. So we're going to walk through each of these. We'll define, measure, analyze, looking at descriptive statistics, and then inferential statistics, and then we'll see where we can improve and see if Bill can control this. I have to admit I got carried away, and this is a bit long, so I'm going to fly through it. Let me know if you need me to stop. So let's figure out a plan. Let's start with defining the project. First thing we always have to do is define the customer. In this case, customer is Bill. And what does Bill want? He wants a health assessment of historical health data. And so I put together a CTQ tree that shows that's what Bill's need is. What's the driver of his need? One driver may be his knowledge of the power of data. His second driver may be his curiosity. So what do we need to do? What are our requirements in order to provide Bill with a historical health assessment? One, we need to make sense of the data set provided. We need to understand historical trends and drivers. and then see if we can digest all of that and provide some actionable feedback to our customer, who is Bill. Problem solving strategy that we took, of course, was the Y equals function of X. Y in this case is given to us in terms of 15 years of health data for Bill. So his blood pressure, his pulse, and his weight. And then X is the process. So anything that contributes to Bill's overall health positively or negatively. So when you look at function of X, that's pretty much Bill's life. So we're not looking to necessarily change the process of which he records the results, but we want to figure out when he pulls one lever, what happens to his overall health. So we'll see if we can make sense of some of that through the data. So first thing I looked at was process map. I think that it's really helpful to map out where the data is coming from in order to make better sense of the data. So I assumed some things here, but Bill wakes up, lies in bed for some amount of time, walks to the bathroom, stands on the scale, remembers his weight, walks to the family room, hooks up his blood pressure and pulse equipment, gets his blood pressure and pulse, writes it down on a pad of paper, walks to the office, logs into his computer, puts it into Excel, and then we've got it there for us. Assuming all of this is correct, and I did ask Bill a couple questions on the process, whether he does this before or after his coffee, before or after reading the news, how long it takes before he wakes up and takes his measurements. So you'll see those red splash points all over here. And these are areas where I identified some opportunities for this process to not be so standardized. So he said 15 to 20 minutes after he wakes up, he takes his measurements. Well, we'd have to ask Bill if 5 minutes is a tolerable standard deviation. Is he okay with it being 15 minutes one day, 20 minutes the next day? He walks to the bathroom. How fast does he walk? Does his heart rate get up this Friday compared to last Friday? He stands on the scale. You know, does he have his glasses on? Is that 6 is 6 or is it an 8? He remembers the weight, but does he remember it correctly? Again, he's walking to the family room. How fast does he walk? Does it increase his pulse? Does it increase his heart rate, his blood pressure? He hooks up the equipment. Is the equipment calibrated? He said he doesn't recalibrate the equipment. And is it the same equipment every time? He said it is. He writes it down on a piece of paper. Again, I don't know how good his handwriting is. I would assume it's pretty good, but in case that 6 looks like an 8, that number might be off. So you can go down rabbit holes with all this information. And again, we're looking at standardizing the process that he records only in the sense that that information at that time is truly indicative of the last week's activity and not just his pulse that was influenced by him walking to the family room. So we cannot standardize the processes that Bill takes between the periods of his measurements, which are every Friday morning. He'd be a robot if he standardized what he did all day, every day. It's just not practical. So this allows us to compare apples to apples. Again, takes out any of the bias of what happened between the time he wakes up and by the time he takes the measurements. So our recommendation to you, Bill, would be to standardize this process as much as possible so you're getting accurate recordings. So we'll dive into the analyze phase, which I kind of split up between descriptive statistics and inferential. So taking a look under the hood, Bill's weight by year did a scatter plot, and you can see that the trend line is trending downward from 2006 to today. So it looks like his weight is decreasing over the data set that was provided. Same thing with pulse. If you take out the outliers, you can see that it's pretty much on the same trend as his weight, which to me, again, not statistically speaking, but just looking at the descriptive statistics of this, it looks like the two are correlated, as you can see in this graph here. So when his weight increases, it looks like his pulse does as well, and then vice versa. So I did a correlation calculation on this, and it said it was 0.38, which shows it's positively correlated. It's probably a weak positive, but it's still correlated.
That's exactly what Steven got.
Yeah, but I did notice that looking at both the weight and his pulse, if you see where the circles are, there's some variation year to year in the range. So one year he might have a high near 198 and a low near 178. So I looked at his weight and his pulse, and you can see that there's some large ranges. I do want to point out that his weight in 2020 was pretty standard, so I have to commend you there for keeping your weight intact, especially during this COVID time. So I took this information specifically focusing on weight, since I knew weight and pulse were somewhat correlated, and I looked at the range in another graph. And so you can see 2007, 2010, 2016, those ranges exceeded the average range of 10 years quite a bit. Again, 2020 looks like he really kept his weight down, or at least the range was the tolerable range. So I wanted to figure out, that's an average range of 10 pounds per year. Seems like it's like something's going on. Maybe he bulks up in the wintertime and then he shreds that weight in the summer. So again, just using descriptive statistics, I looked at his weight, and sure enough, it looks like it bottoms out somewhere between May and August. His weight comes down, builds back up in the fall and winter months. So knowing that it was somewhat positively correlated to pulse, I assumed I'd see the same thing, less drastic with pulse, which I did. You can see his pulse is also at its lowest point in the summertime before climbing back up in the winter and the fall and the winter. So wanted to move to blood pressure, but not too familiar with blood pressure. So I had to look up what those numbers meant. They meant nothing to me on paper. And it looks like they are categorized into 5 different categories: normal, elevated, high blood pressure stage 1, high blood pressure stage 2, and we won't worry about the last one. So you can see that, if your systolic blood pressure is this and diastolic blood pressure is this, then you're in one category. Once you get to high blood pressure, you get to the ORs. So whether it's too high in systolic or too high in diastolic, not in both. So what I did was, for each data point that I had, I assigned a blood pressure category. So you can see this blood pressure category over the 15-year period. So the orange is high blood pressure stage 2 as categorized by that website. The darker blue is stage 1, and then the lighter blue will get to elevate and back towards normal. I do have to say that some research did find that pretty much everybody over a certain age gets into a high blood pressure stage based on that categorization. So don't look too concerned, Bill. I don't think it's any reason for concern, but just wanted to show it graphically. So I want to take a deeper look at this and kind of put it in the control chart. So you can see, now this is 98% confidence interval, so it's going to sway a little bit more than the other ones. But 2006, 2009, 2017 really stood out with the systolic blood pressure. They're exceeding the upper control limit. And then you can see it on the diastolic side. You can see it's kind of those same years. This one was more 2016, 2017 was increasing the blood pressure on the low blood pressure, which helps describe why we saw this peak here in 2016 through 2018. So I was a little surprised with this because the weight was decreasing, the pulse was decreasing. I expected the blood pressure to improve, but it looks like here in 2016 through 2018, blood pressure got a little bit worse. So I was a bit confused by that, but I wanted to take the findings from the descriptive statistics and kind of categorize them before we move into the inferential statistics. So you have 2006, I categorized as bad. 2007 to 2015, good. 2016 to 2018, as we know, it started to dip back down. We'll call that, we're going to say that's yellow light. And then 2019 today, we saw, based on the descriptive statistics, that looked like his health was improving. So again, coming back to this, we're pretty much looking at what should Bill do more or less of in life based on the outputs that we have and the timeframes. So can we break it down into those 4 timeframes and say, if our statistics are right and it was better between 2019 and today, focus on doing a lot more of what you did in those years. So the first thing we did was looked at the normal distribution for each. So for the blood pressure, the pulse, and the weight, and it looks like they're all normally distributed. So those green check marks say we can go ahead and move forward. So I looked at the correlation. Again, we knew that pulse and weight was this 0.38. So we knew that that was somewhat correlated, but not perfectly correlated. So I noticed that systolic blood pressure is probably the best correlation relative to all the others. I'm going to call this total correlation. I don't know that that's statistically accurate. I think that's just me BSing, but I'm going to go with them and say it was 1.34. It's higher than all the others. So I have some reasonable assurance to say that systolic blood pressure is indicative of the others. So I'm going to focus on systolic blood pressure again to confirm whether these groupings are accurate. First thing I did was a Z-test and said, is 2006 statistically different than the other 14 years? And it looked like it was. It was over to this right tail on this red area here. So we can say 2006, bad. Descriptive statistics agreed with the inferential.
That's when I
So
dropped in
narrowed
the
it
shower,
down.
by the way.
What's that?
That's when I hit the deck in the shower. I looked in 2006.
What happened?
It just,
You hit the
Hit the
deck in the
deck.
shower either? Oh, geez. Oh,
that's why I
that
started keeping track.
That explains it. Well, good. Now we have some boots on the ground to confirm 2006 was bad. All right, so 2007. So we left those three other categorizations, and we wanted to pretty much look at, are these different? And if so, then we can say then what was happening in the last 27 months has positively impacted Bill's health. So null hypothesis is there's no significant difference between the three groups. Alternative would say that there is. So since we're looking at groupings, I did an ANOVA test. So the F score here is greater than the F critical, which allows us to reject the null. And it says, yep, okay, this agrees with what we looked at earlier. Those three groups, there's no significance. There is a significant difference between the three groups, which we were hoping for since one's yellow and two's green. So then we want to look at, again, looking at the systolic blood pressure, is there a difference between these two, just as a final catch-all, make sure we've done our diligence. Did an ANOVA test again, and you can see that the 2.5 F critical, F value is actually less than the F critical of 3.8. So it's close, but we cannot reject the null hypothesis. So this all of a sudden was like, oh man, we don't have really reliable data to give to Bill. So again, I had mentioned earlier that systolic blood pressure, I guess, rises as you get older. So can we really rely on this? So we did an ANOVA test with weight and with pulse. And again, the same thing. Weight, same null hypothesis and same alternative. And the weight showed an F value greater than the F critical, which said, okay, we're back on track. We can reject the null hypothesis and say that these two periods are not equal. Did the same thing with pulse, and you can see F exceeds F critical. We can reject the null hypothesis. So again, we can say that these two periods are not equal. So our observation here is what your health did decline between 2016 and 2018, but 2019 to today, the last 27 months, you've made some improvements. So we want you to keep doing what you've been doing, since those have been the inputs in order to get your health numbers that we were able to analyze. So if you could think over the last 27 months, what have you done different? Whether changes in diet, changes in exercise, sleep, stress, think about it and continue to focus on those positive contributors. And then to improve, create a plan and stick to it. So we know that there's 4 things that impact your health. It's exercise, diet, sleep, and stress. So try to improve on all of those. And then to control it, again, create that plan and stick with it, track your results, and find out ways to standardize what you're doing with things that work. That's it.
Wow.
Wow, that was impressive.
Well, he
I
does
got
it for a
carried
living.
away. I didn't know
Yeah.
where to stop.
That was great. Good job, Brendan.
Thank you.
He does it for a living.
That's true.
That's how he's wired. I think everybody made data talk. That's the whole point of the whole exercise, because it just kind of lays on the page and just whatever direction. Oh, that was really good. Really good. Thank you guys. Thank you so much for letting me do this. I'd like to talk to you, Sergio, about, because I definitely want to do more of it, but I don't know if the time, we started what, in November, late November, something like that.
Yeah, something like that.
Yeah, maybe the different strategies to condense it. Maybe one taped one and one live one a week or something. So we do 2 a week. But I'd love to talk to anybody else has any suggestions like that, because I definitely want to do more. I enjoy this a lot, seeing you guys. But thank you so
It was
much.
great. I guess again, it has to do with the level of the participants. I mean, within Ulbrich, I know Brandon and Steven, probably it was like a refresher even, or something that they know exactly what the concept is. For me, man, it was tough. I enjoyed it, but it was very difficult.
Okay.
So maybe you wanna have the groups to be more, I don't know, think about who you engage in your groups. Because maybe Stephen and Brandon were bored in some of the passages, and Daniel, just to mention. And for me, and man, it was a little challenging.
But I think that like I said to you, like there's times when you would say, hey, wait, whoa, time out. And I think like you have the gift of saying what everybody else is thinking sometimes, I think. So it's kind of like you're calibrating the class a little bit for me. So anybody wants to tune in on Friday, I'll send you the invite for Sean. Otherwise, I'll probably tape, I'll record it and get Sean's off to you. And then you'll be getting a certificate on your email, suitable for framing. Yeah, put it on the wall. But,
Nice.
Well, I think you're put in the tough situation, Bill, where you've got to cover all the things that you're required to cover, but while focusing on the things that are actually important. So it seems like a lot, but I enjoyed it. I liked seeing it from your perspective, breaking it down into simple.
Well, thank you.
Yeah, no, it was good. It was very good. Just a little bit outside some people's comfort zones for sure. But, we learned a lot in a short period of time, and it was taught well. It really was. It's just now you got to work with it.
Well, even like as a black belt, there's probably 2 or 3 tools that I'll use, regularly. They took away from all that hours and hours of training. So that's kind of what I was hoping for. What are the things that you find are important? And
sure.
Yeah.
It's like I said, it's interesting to see the people that use it a lot or have a good background in it, what they come up with. I mean, Brendan's presentation was crazy.
It took him 8 minutes.
I know, probably, but it was nuts. Like I would never have thought to go that route. Like it was absolutely nuts. Sometimes we get caught up in the little things, like trying to figure it out, and it's really nice to see everybody's different levels and what it could be, and where people are starting.
Yeah. Well, thank you guys so much.
Yeah, maybe the hypothesis testing. I feel like it was hard for me, but like for future, maybe if you went over that a little more.
How about what if I left some out? Like, in other words, say there's 20 tests, and I don't even bother with. I mean, I have to mention them, I guess, part of the course, but I don't know if it helps. Like maybe it'll help if I thin the herd, because you're getting one after the other, Same thing with control charts, I think, to some degree.
True.
Maybe that would help, Daniel. Like it wasn't just so many thrown at you, especially the ones you never use, probably.
I just maybe more in depth with like the most important ones, like maybe like student T and like Z test.
Yeah.
Maybe just like really like hammer that down.
Maybe homework on those more.
Yeah.
I like where Sergio went too, because like I was thinking you're going towards non-continuous data, with your assessment of the CRM, which was cool.
Yeah,
Anyway.
I would be interested in knowing from Brandon, for example, which tools he uses the most. I mean, I've been working with Brandon a few times, and it's the second time that I've seen his presentation, or the third times. He enjoys the what's called the swimming pool lanes.
The process mapping.
What's it called?
For the process mapping, the swim lanes and the process.
The swim lane. He uses that a lot, and he goes, it's the third time I see that job in your, that process in your job. It would be nice to know which ones are the instruments that you use the most, and try to learn more and maybe grab those as well. But it depends on the job and the scope, I guess.
Yeah, that just helps me visualize and get everyone on the same page that that's the process. That's what everyone's doing, and gets everyone in agreement before we start. But I think what tools to use really are specific to what problem you're trying to solve. And
yeah, I think it's that's the beauty of leveraging diversity as these 3 to 5 people teams, because we all think differently. All right, thank you, man.
I will.
Have a great afternoon.
Thank you.
I'm gonna go
thank you,
work on
Bill.
my health.
Appreciate it.
See you guys.
All right, take care.
Thank you so much.
Thank you.